All right, so for this video, what I'm going to be doing is go over some real life linear functions. And we're going to talk about writing equations in slope-intercept form. So we need to know slope and y-intercept. And we're going to do that from tables and from graphs. And then we're going to be able to take something that's real life and describe what the slope and the y-intercept actually mean. So let's go ahead and get started. The first thing we're going to talk about is what a relation actually is. A relation is just a set of ordered pairs. So it's just a whole bunch of points. So for instance, because you see these points on the graph here, that makes a relation. Those points are just ordered pairs. And I'm going to make this a little larger so you can read this point here. Every point consists of an x and y coordinate. The x coordinate is first, just like the alphabet. When you say your ABCs, you say x, y, z, not y, x, z. X before y. So I will go to the x-axis, and this is 0, which we call the origin. I go over 1. So this point is at an x of 1. And it's up on the y-axis, 1, 2, 3, 4, 5, 6, 7. So that ordered pair can be labeled as 1, 7. And the reason why ordered pairs are really important is because, take for example, planes. Planes have to have locations or ordered pairs so they know where to land. That have to have a spot for their destination. So each one of these or the locations are labeled as ordered pairs. All right, let me just take this one, for example, and label its x and y. This x is actually at 1, 2, 3, 4, 5, 6, 7, 8. But the y coordinate doesn't go up or down. It's at 0. We didn't go up, nor did we go down. So the y coordinate is 0. All right, that's how you label ordered pairs. But just a bunch of ordered pairs together make a relation, okay? In this particular relation, they form a straight line. These points form a straight line. If you have a graph that forms a straight line, we say that that graph is linear. And in linear, you see L-I-N-E for line. Linear relations can be represented several ways. Number one, they can be represented as a graph. 2, linear relations can be represented in table form. They can be represented just as a set of ordered pairs, in a mapping, and 5, in an equation. But you should have learned that from watching the video from Monday, the one I assigned for homework. If you didn't watch those videos, you definitely need to go back and watch them because all the information is on your ACAP test. All right, so let me give you some examples of what linear equations look like. Linear equations can be in this form, and we call it standard form. This first one here is called standard form. When you have x and y on the same side of the line together. This example is in what we call slope-intercept form. Slope-intercept form is when y is on one side of the equal sign by itself. And for these, the easiest form to me is when y is on the side by itself. So the easiest form to work with is slope-intercept form. Linear equations can be written in standard form or slope-intercept form. Again, here's standard form. We have ax plus by equal to c, or slope-intercept form, which is y equals mx plus b, or y equals mx. So I'm going to break each one of those forms down so you can know what each part means because they actually mean something. So we're going to start off by trying to break this down, standard form. So if I break down standard form, I need to know what each part of it means. A and B are called coefficients. They're the coefficients of x. A is the coefficient of x. And then B is the coefficient of y. And then as far as C is concerned, C is just some constant. And a constant, guys, is just Write this down. It's just a regular number. That's all a constant is. It can be positive or negative, but it just needs to be a regular number, okay? All right, so let's talk about what the variables x and y actually represent, because we know a and b are coefficients. A is a coefficient of x, b is a coefficient of y, c is just some regular number. But what does your x and your y, what does that actually mean? What do they represent? So x is going to be our independent variable.